Hi. So, we will be today discussing on a aspects of this a special aspect of this database or more of a spatial database, right. So, I believe that most of you are accustomed with database management system or DBMS, or more specifically the today's relational database management systems, and we will try to look at a overview of this, how this spatial database how it differs from our traditional database systems or non-spatial data handling type of things, and why we require a little bit special type of treatment for this. So, that is our bottom line, and slowly from this database we will go for the query engines and other type of things. So, that we have the spatial database operations into the play. So, mostly we will be looking at some of these concepts, and we most of the things will be, many of the things will be expanding in our subsequent lectures. So, if you look at our traditional database management systems, so it is very robust these days, right. So, starting from banking to say library, ERP systems and other etcetera, it works pretty robust. So, it is persistence across failure, allows concurrent access of users, right. So, it is scalable to search queries for very large data sets which does not fit in the main memories. So, that is still a challenge, but it can handle. Efficient for non-spatial queries, not for spatial queries. Why? We will see, right. So, this traditionally our database systems or DBMS or relational database systems has matured to a great extent, or where it has some sort of a foolproof mechanisms, right. So, there are non-spatial, several type of non-spatial queries, like list all students of a department, list say all in the medical stores in Kharagpur, or list all students of a particular hall, or all residential students etcetera, which are typically non-spatial or what we say traditional queries. We are used to it again, right. Find out the libraries, books in the libraries with this particular author or a particular subject, or something like that, or a particular publisher, etcetera. These are there. But we have to, we may look into the some of the spatial queries, names of like main all medical stores which are 5 kilometer within the IIT Kharagpur, or like we had some of the queries like if this particular river or a drainage is flooded, so which are the areas likely to be, in which are the villages likely to be inundated or partially inundated and type of things, right. Or find out that which are the say something schools which are within say x kilometer, 2 kilometer from say state highways or etcetera, right. So, these are the things which has a spatial context, like if I want to say that within 5 kilometer of IIT Kharagpur which are the bookstores or which are the medical halls or medical centers, then I have to find out this buffer of 5 kilometer. So, it has a context on the things, right. I have a 5 Kharagpur and a buffer, and then need to overlay, find out which are the medical stored in that locations, right. So, there is a coordinate systems coming into play, right, and this as you understand, it is pretty cumbersome to handle with non-spatial or traditional data sets which we are used to, right. So, like list all customer who live in West Bengal and is adjoining state. So, what is the definition of adjoining state, right. So, I can say adjoining states are the states which touches West Bengal. I can say adjoining states are the states whose boundary is within so much kilometer of that. So, it's something which is has some geometry, some coordinate systems into play, right. So, these are spatial things, and that handling this with our non-spatial database systems is a challenge. So, example of non-spatial like names of students name, roll number or department etcetera, or a library book name, type of say authors or a author's name, publisher name etcetera, which are accession number. These are all spatial non-spatial data sets, right, or even anything for that matter, like if you look at the banks, there are all attributes, etc. Whereas, if we look at the spatial data to be stored, like satellite imagery, right, images taken by these satellites, right, or even airborne anything or a drone, etc. How do I store that? How do I search that, right? How do I query on that? That is a challenge. Even road, river, vegetation cover, these are all things, like road is a linear thing, this polyline, river may be a polyline or a polygon, vegetation cover may be a polygon, weather and climate data, right. It is we come with a spatial context, right. Even if we leave the if we go little broader from the our geospatial concept to a basic spatial, like considering a human body as a space, then medical imaging type of things are there. Even census data, that is very typical, right. Census data like a, say population map or different demographic data, these are not seen from the space, right, but they are related to something, right. I say the population of India is so much, population of Kharagpur is so much, population of say West Bengal is so much, or population of say Bihar is so much, right, population of a particular Musa, etc. So, that means this data is a context, or I say literacy level of this is this, or this much population is affected by this and a type of things, right. They are so much is above this age and type of things of this particular region. Whenever we come to a region, location, etc., then we have a context into the play. So, in that sense, the census, though as such may be a non-spatial or traditional data set, but connecting with a some coordinate systems become a spatial context. So, spatial database management system or DBMS or HDMS, if you in short, if we want to tell, so can work with underlining a DBMS, right. So, DBMS is a standard, right. It has grown over years, proven over years, and then it is a underlining DBMS, supports spatial data models, right. We have seen the spatial data model, this should support data model, spatial abstract data types, query language from which these data types can be callable and all those things, right. So, I require a database, spatial database which understands spatial data models and spatial ADTs or abstract data types and etc. Like it should understand what is point, polygon, etc. It should understand topological relationships, if I want query that whether this touches this overlap this type of things, right. Support spatial indexing, right, that is important, we will see in subsequent things. Spatial indexing, efficient algorithm for processing spatial operations, right, and domain specific rules for query optimizations, right. So, that we will see when we look at the things, but it should have a spatial indexing, right. Like there is a inherent locational property of the things, right. Like we say that nearby objects are likely to be more close values than distance object. Like I say, temperature of this particular outside this particular building is likely to be same or nearby than the subsequent building, than this temperature of IIT Kharagpur a particular outside on some things that and will be same as Kolkata or Darjeeling or Simla and type of things, right. So, the more distance more nearer things. Now, when I search type of things, whether it is necessary that this type of which are in the same cluster, the data should be in the same place, but there is no as such this type of things in case of a non-spatial data, like on the spatial context, right. Different tuples are not that way related, they may have a meta relationship, but that way not related, that nearness and type of things, right. So, there are several examples, like we have different database players starting from open source and etc., like MySQL to Postgres to Oracle Spatial, and there are specific tools like ISRI, SD, etc., specific proprietary things which are able to capture the spatial context, like spatial data types like polygon, polyline, point, spatial operations like overlap, join, touches, intersects and etc., and those are callable by SQL or SQL3, and there are spatial indexing strategies, we will see that art trees and type of things, right. So, I can have spatial data sets like region, boundaries, black, anyway that figure is not there. So, forget about that within the bracket, black line and all those things. So, region, boundaries, forest name and boundaries and water bodies, etc. So, those things are there. Storage may be like looking at a census block, if you see that Shashi Sekhar's book. So, has a something like you see, it has a name, string, float, number and a polygon. Say I consider a river. So, river may be having a name, a particular some other properties and then has a feature like polyline, right. I say a IIT Kharagpur region, right. So, it has some of the non-spatial attributes and some spatial context, right. That means, whether it is a like in this case boundary is a polygon, right, a road may be a polyline and type of things. Now, how do I represent this? Like if we consider a square block, in this case a census block, then one is that I give a number, area, population and I define the poly as a polyline like this. Now, my polyline, if the source and destination are same, we say it is a polygon. So, if the source and destination touches each other. So, this is one way I can represent. So, we can argue that whole thing I could have done in a standard database also, right. Like I some way I represent that these are the points there in that particular polygon and type of things. It could have been nice that if the polyline is defined or polygon is defined in a direct sense. Now, traditional relational database has support simple data types like number, string, dates and there may be little bit of complex data types. Modeling spatial data types is a very tedious on the things, right. It becomes more a tedious effect like that, like making a polygon. I have a number of polyline, from the polyline every has to be defined by different points which connects to the lines and it's become a tedious things. So, modeling of polygon using numbers. So, polygon or edge or polyline and points. So, polygon is a polyline where last points and first point or starting point and ending points are same. A simple unit square represented by 16 rows across 3 tables, what we will see. Operations like area requires joining of these tables and it is computationally intensive like as we have seen. So, some polygon, so it has a boundary, that boundary has to be written by the edges. The edges has some start point, end point, every these points has a coordinate. Now, see a single unit square I require so many things. Now, if I have some operation like finding the area of the things, now I require joining these tables and doing calculation and type of things, right. So, it is possible by traditional data set to model this, but whenever I want this type of query which are like area of a particular region or length of a things, I require so many tables to be joined, etc. So, I require a smarter solution. Underlining DBMS is there, over that I require a smarter solutions which will give me a quicker results. So, we have some of the things of post relational databases like support user defined abstract data types, right. We have that user defined abstract data types. Spatial data type polygon can be added to that. So, I can say the user defined data types is a polygon and the definition of the polygons is come into play. So, choice of there are several choices of post relational database we can have. So, a spatial database is a collection of the spatial data types, spatial operation, spatial indices, processing strategies of this and anything on the spatial, and that can work with many post relational DBMS as well as programming languages, right. I can have different programming languages like Java, etc., which can work on the things, right. So, first of all it can handhold with the spatial data types, operators, indexes and the processing strategies. I may have different type of processing strategies for the things. We will see that when we look at the query processing, etc., right. We can have different processing strategies like how do I calculate area, how do I calculate intersections. So, there should be a strategy, some algorithm should be there. How do I find shortest path, right, on a network of roads or network of transportation network, how do I find a shortest path. So, there should be strategies. So, that is important. Okay. So, GIS is a software to visualize and analyze spatial data using spatial analysis functions, like. So, another part we will come to that in a little detail. So, there is a geographical information system. There are different variation of this acronym. People sometimes it is geographic information sciences and several other things, but primarily it is a software tool. Sometimes why we are mentioning this? Sometimes we will try to mix up with this GIS with the spatial database SDMS or spatial database management system, but they are not exactly same. GIS uses spatial database management system, but GIS is a much higher level, right. So, it is a software to visualize, analyze spatial data using spatial analysis functions like search, locational analysis, terrain analysis, flow analysis or distribution, spatial analysis and statistics, measurements or several type of measurements. So, these are the properties of GIS. So, it uses the underlying SDMS, but they are not the synonyms, like I cannot say GIS is this and type of things, right. So, it uses spatial database management system, store, search, query, share large spatial data sets and so on and so forth. So, HDFS focuses on efficient storage, query, sharing of large spatial data sets. Typically, the spatial data sets not only have this type of geometry property, they are usually pretty large, right. So, handling this data is a big challenge. Provide simpler set based operations like search by region, overlay, nearest neighbor, distance, adjacency, perimeter, etc. Right. So, if you look at the spatial context, we want to find out how much near I am to, even I am to find out that from this to this, I may not have the whole data, but or that last mile connectivity, I will find out the nearest things which are there, right, or within 1 kilometer of the road, within 5 kilometer of the river, within 10 say 2 kilometer radius of a factory, and there are different, that pollution will be so much human, I can say that this is a chemical factory and within 10 kilometer there should not be any population or human habitation. If it is there, then we need to trigger medical checkup and other things for them on a regular basis. That may be a regulation of the government, right. So, how to do this 2 kilometer overlay of the region, finding out from the population match who are the affected, who are likely to be affected by this particular factory or any type of things, right. So, there are different operations which you need to do. So, it is a software system, if we recap again, can work with underlining SDMS, supports spatial data models, spatial entities query language, supports indexing algorithm, etc. already we did, just to recap. So, there are several components, right. So, spatial data model, query language, query processing, file organization, indexes, query optimization, etc. These are the different components. If you try to relate with that, for our normal databases also different components are, but there is a spatial context into it, right. So, need to be dealt with in a little more I should say smarter way, or on a or more in a spatial way, quote unquote spatial way into the thing. So, this figure is if we look at it, so again 3 layer architecture. So, it is broadly, no need of immediately break your head over this. One side is this different type of application, GIS, MMIS, CAD, which takes this input from the things, and other side is the basic database management systems, right. So, underlining database, because this is a working thing. Here we have the spatial things in the, its core is spatial taxonomy, spatial data types, spatial query language, these are the core. One side we have the abstract data types, data models, interpretation, networks, data volumes, visualization. Other side we have the interface with the database. How do I? So, there is a index structure has to be there. There are issues of spatial join, whether the same as that our normal join, right. How do I spatially join 2 polygon joining and to a student table or a department table, student table and a hall table joining are not the same thing, right. So, it is a to spatial data joining how there. So, spatial joining, cost function of selectivity evaluation, when we do some selection, what should be the cost function, views of derived data sets. So, bulk uploading, concurrency control, etc. all this. So, there are one is that interfacing with the database, one is interfacing with the spatial data analysis tools, and another is the core, right. So, this is the whole stuff which comes into play. So, what we require is if we look at that there are spatial taxonomy and models, right. So, what do you mean by spatial taxonomy? There are multitude of description available to organize in space, that how it organizes in the space. So, topological model, homomorphic relationships like overlap, and we have seen the topological models and how they behave. Euclidean space model like distance, some of the Euclidean space model like distance, direction in a plane, right. Graph model for connectivity, shortest path and type of things, right. See if you look at this overlap and other type of things, or adjacency, touching each other, etc., that is one context. Other, there are different graph models, right, when we try to look at say shortest path, right. So, that is not the crow-fly path, right. So, I like if you I have a building here, a building at the other side, in between there is a wall, right. So, the distance to between this Euclidean distance to building may be 200 meters, right. But if I want to find shortest path, I cannot do scale this wall, I have to go to this through this path, etc., which may be 700 meters, right. So, though this is other way near, but when we consider this road network to finding the travel time, etc., it is much far, maybe the something which is 300 meters away on the road is nearer to these things, right. So, that in other sense, the spatial networks need to be dealt in a different fashion, right. So, that is why we will see here also that we need to look at these spatial network operations in a different fashion. Then we have that spatial data model, rules to identify identifiable objects and properties of space, right. Object model may manage identifiable things like mountains, cities, land parcel, etc. So, field model, if you recollect, we discussed some of this object model and field model in our previous lecture. Field model helps to measure continuous and amorphous phenomena like wetland, satellite imagery. So, where the continuous changes are there and type of things, right. So, we need to, what we mean to say, these are the things need to be accommodated by the spatial database management system, right. So, that we can work with the things. One aspects of the things we will be dealing this in much bigger details is the spatial query language, right. Like point, line string, polygon, or point, polyline, polygon are different data types. Spatial operation, overlap, distance, nearest neighborhood are the different operations. So, callable from a query language SQL3 underlining DBMS, select s dot name from senator, say particular senator or administrator is where district name area is greater than 300, etc., that may be a query. Now, you see here the last line is doing some operations like a particular distance more than some 300 units, only that I require the district administrator name in or something, some MLA or something, in this case senator, etc. Standards. So, there are several standards which also evolved. SQL3 is a standard for query language. Open geospatial standards or for spatial data types and operation, otherwise there will be problem of having a standard set of the things. So, both the standard enjoy widespread support, both from industry, both from different federal or government agencies which follow these standards. So, like the square is select some S name from senator, etc., where the area is 300 within B location and S district, right. So, see these functions, area, within these are typically not there in our standard traditional database systems. So, these need to be accommodated. Like non-special join this senator where something social security code and gender, female, these are non-special things. Now, if we want to join, I have to join like this. So, district polygon with point location, the spatial join has to be there, this is a normal join. So, wherever the spatial context is there, I need to go for a spatial type of join. So, how it looks like, right. So, we will come to that. Just what we are trying to do, we are trying to open up these scenarios where these things are make sense or make important. So, which try to impress upon that there is a need to look at the spatial database management system in a different way, not as it is something more than our traditional database management systems. So, whatever the traditional things are there, so that is there, but we need to look into the things. So, like if you say we need to feed efficient algorithm to spatial queries, right. So, there are two things, one is to filter the things, right, another is refinement, right. Like say for example, I want to have a overlap of the things, right. So, so we will see that what is the MBR? MBR is the maximum bounding rectangle. Suppose A is like this. So, what is the maximum bounding rectangle? This is the rectangle, right. So, B is like this, this bounding rectangle is this one. So, C is like this and the bounding rectangle is like this, right. So, if my query region is something like this, I want to find out that where is the query region, etc. Now, these are polygon. Okay. So, this querying on this, that what I have to do, that if I want to find out whether which are the regions which falls within these things A, B, C, D, whether they fall. So, first of all what I have to do, I need to basically in a very crude method, every coordinate I have to find out whether this my query region or region of interest, whether they falls into the things, right. And if it is a irregular shape, it is a very difficult or tedious job, right. I can do a filter steps. I say a maximum bounding rectangle or MBR or some or MOBR sometimes we call. So, that is rectangle. So, for every region A I find out the rectangle, B I find out the rectangle, C I find out the rectangle, D I find out. If my query region is not overlapping with these rectangles, right, query with their MBRs, then it will not overlap with the particular object also, other way it is not true, right. So, if it is overlapping with the MBR, that does not mean that it will overlap with the actual object also, but nevertheless in doing so I could bring down the search space, right. In this case I can easily eliminate A. A is nowhere in the things, because A's MBR is not overlapping and MBR is a rectangle. So, comparing two rectangles or multiple rectangles is much easier than doing a irregular polygon shape, right. So, this is the in the filtering step I eliminate B, right. Still these things are there, but what we can see that finally in the refined state I can eliminate C. So, how we can go about this is another challenge, but nevertheless my first one is a filtering, bring down the search space, and second one is go for a refinement stage or more detailed thing, so that I actually find out the things, right. So, that is the way of looking at it. And there is also the query processing of spatial of join queries. When there is a join like this, then there should be a way of things to lay. One typically I have a sweep line, right. So, the sweep line says that where if it is passing through that, it is cutting the things, then I say there is a possibility that there will be a likely there may be a chance of these two rectangle overlapping, there is a question of join, right. So, I can have horizontal, vertical sweep and type of things, and then can find out which are the potential candidates who are likely to be the participate in the join operations. So, this is another challenge. File organization is another major challenge, right. So, GIS and HDFS operations requires GIS algorithm data sets loaded in the main memory. So, GIS algorithm typically want that to be main memory. SDBMS data set in the secondary storage in the disk. SDBMS uses space filling curves or spatial indices to efficiently search the disk resident large data sets. So, it is a space filling curve, it is not like row wise etc. I may have a space filling curve, that means nearby objects should have a consecutive sequence number, that means they should be localized in the disk space, right. So, there are several strategies, we will look into the things. One is, this is a row order, but this is a Z order, right, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. So, what you 5, 6, 7, 8, what you see that these are localized, that means these instead of this in a continuous line. So, in the disk what will be there 1, 2, 3, 4, 5, 6, 7, 8 like this, right. But see what is likely to be there, these are likely to be nearer, but if it is in a row filling, in this case after 4th it will come, right. But if I can have this type of space filling, then I can have this data much quicker than on a elongated space, right. So, this is one of the things we will discuss. So, sorting is not naturally defined on spatial data. I cannot sort on the spatial data naturally, right, which is there in the traditional data set. I can sort on something, student name, student marks, or etcetera, some sorting algorithm, but how do I sort on the polygons, right. So, there should be some way to look at, right, whether there is a nearness in the things or sorting the polylines, polypoints, etcetera, what should be the basis of the things. Many efficient search methods are based on sorting data sets, right, whatever the search etcetera, it is basically based on it traditionally, right. So, this is has to be there some of the ordering stage. There is another that indexing scheme like B tree and hierarchy collection is linear key is a very popular, B plus trees are very popular, whether that is also applicable here. So, there is a concept of art tree in a hierarchical collection of rectangles, right. So, like this I can represent as a art tree, R plus tree and type of thing. So, indexing is also a challenge. Then finally, come as a query optimizations, right. Like if I say that say which operation I should do first, right. So, if I have a number of select, project and other spatial operations, whether I can do what should be my sequence or what should be my query execution tree, that is important, but that brings down the data load. This is important for our traditional data or traditional systems or database systems also, where which need to be there, like whether I should check this one first or this one first to be process gender female before this may give me a much faster things, because it may be more the data set will reduce and type of things. And here the things are there, if I have spatial operations, then whether I want to bring the non-spatial operations into much lower into the things, right. So, we will see that. So, this query optimization, finding efficient query execution trees are important. And another aspect is what do I want to do, means what next, right. Query is one of the things. Another is that I want to do some sort of a data mining, right, spatial data mining into the things, analysis of spatial data of many types, deductive queries, inductive mining, statistical correlation, clustering, classifications, right. So, data mining is a systematic and semi-automated search for interesting non-trivial pattern in the large data sets, right. For spatial dynamic large spatial data sets, right. How do I mine those things? What are the spatial mining systems, like which are the correlated operation, co-occurred operations, co-occurred situation or events I need to mine and find out. So, these are non-trivial. If it is trivial, then I do not need all those things, like identifying dengue cluster and geographic factors with a high correlation in a particular region, right, or crime hotspot to assign police patrol and social workers or something like that, right. So, what are the crime hotspot in a city or a region, so that because my police resources or the security resources which are much constrained, not that these can be resources. So, what we look at in look at a overview of the things is a valuable to many important applications with a spatial context, works with underlying database management systems, provides spatial entities which are callable by spatial queries, provides method for efficient processing of spatial queries, and there are several components like spatial data models, spatial data types operators, spatial query language, processing optimization, data mining, and there are several we can go on adding these things. So, HDFS is used to store, query, share spatial data for applications like GIS, right, as well as several other applications. So, what we tried to today to have a overview of the whole how what is this spatial database management system. So, that this brings our foundation for several other things when you go for spatial queries, optimizations, spatial networks, etc. Right. So, that we will cover in our subsequent lectures during this course of during this lecture series. Thank you.